Hi everyone, welcome back to another video on problem solving. In the study session today, we're going to look at another physics and maths problem, and I'm going to go through this problem with you from scratch. I haven't seen this problem, and I hope you haven't either, so we can really dive in to look at the nuanced ways in which we can solve this problem. So let's get straight into it. The question states, a small object of mass 10 kilograms is suspended by 3 light inextensible strings which are fixed at the points 0, 0, 4, blah 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 blah, in a right-handed coordinate system in which the z-axis points vertically upwards. Each of the strings is of length 4 units. What is the highest tension in any of the 3 strings? So let's think about the configuration. So we have a small object of mass 10 kilograms. It is suspended by 3 light strings, which are fixed on a specific point, and we're told that each of the strings is of length 4 units. So essentially, in our minds, what we know already is that there are approximately 3 strings, like this, and then there's an object of mass 10 kilograms like such. So here we ask, what is the highest tension in any of the 3 strings? So in order to figure out the highest tension, we know that we're probably going to need to resolve the forces so that the string that provides the most vertical component of the gravitational force would have the highest tension. Or alternatively, what we can say is, what we can notice is, despite the 3 different coordinate systems, different x and y axes, all 3 of those coordinates share the same z-axis, which means that they are located on the same plane. So essentially what this looks like, if you draw out the z-axis, and let's say this is the xy plane, is the 3 points are located somewhere in a plane of height 4. And they are connected such that the object hangs from 3 points in the same horizontal plane. And so now what happens is we need to find out which of the string has the most vertical component of gravity. Now let's draw a horizontal coordinate system like this. This y-axis, this is the x-axis. One of the points is located at 0, 0. The other one is 3 root 3, 3. The root 3 is about 2-ish, so we can say about 5. And root 3 and 3, yeah, so that's 3. Another point here. And then 0, 6, so a point around here. So those are the 3 points. And we are told that each of the strings is of length 4 units. So obviously here we can see that the location where the weight will be hand down is going to be the center of the triangle formed, like this. And we would suspect that the location would probably be the center of mass of the triangle, which is also okay, so now we need to determine the center of mass of this triangle. In order to do that, I think the center of mass is the intersection of the center lines of the 3 triangles, which is this point here. That's the center of mass. And the thing about the center of mass is it is not equidistant from the 3 points. Oh, I think it probably is. Yeah, the center of mass is equidistant. So it's equidistant. And we know that if the horizontal component of the distance between the mass of the weight that's being hung down and the 3 points are equidistant, then the vertical components of the weight must be the same. So if the vertical component of the weight is the same, then what we know is, well, each of the string would share a vertical tension force equaling to the weight divided by 3. So 100, or let's say 10g divided by 3. That's going to be the vertical tension force on each string, because they are essentially the same. Now what we've got to do is to determine the horizontal tension force, because we're asked what is the highest tension, and the tension would be the vector sum of the vertical component of the tension and the horizontal component. So from the setup, what we need to determine is the distance from each of the point to the center of mass. So in order to do that, what we need to do is quantify the points. So this point is not 5, it's actually root 3. So now what we got to do is determine point x here. Let's name it x, such that the two distances are the same. Those two distances are the same because it's a centroid, the center of mass. How we're going to do that is, according to Pythagoras' theorem, root 3 squared plus x squared. 3 squared plus x squared is going to be equal to 3 root 3 minus x. So this distance is equal to that distance. And so root 9 plus x squared is equal to 3 root 3 minus x. Next step, what we need to do is square both sides. So we get 9 plus x squared is equal to 3 squared is 9. 9 times 3 is equal to 27. 27 minus 6 root 3x plus x squared. We eliminate x squared on both sides. We get 6 root 3x is equal to 27 minus 9 is equal to 18, I think. Then you can divide both sides by 6, so root 3x would be equal to 3. So x would be equal to 3 over root 3, which is root 3. So now we know that x is equal to root 3. So distance, horizontal distance, the horizontal distance would be equal to 3 root 3 minus root 3, which is equal to 2 root 3, and that is the distance between the mass, between the mass and center of mass. So now what we've got to do is so we've got the vertical distance is 4, the horizontal distance 2, 3. We can work out the vertical distance. Vertical distance there would just be root 4 squared minus 2 root 3 squared, which is equal to root 16 minus 4 times 3, which is 12, which is root 4, which is 2. So we know that 2 divided by 2 root 3 is equal to 1 over root 3, and that is also equal to the vertical tension force divided by the horizontal tension force. And we know that the vertical tension force is 10G over 3. 10G over 3. So the horizontal tension force, we can work that out to be 10 root 3, 10 root 3 G over 3. And so the total total tension would be the square root of Tx squared plus Ty squared. And that would be, let me see what answer choices they've got. If it includes G, we'll include G. If it doesn't include G, we'll just use 10. So here, the answers include G. So if it includes G, then we would have to include G in this instance. So be 100 over 3G squared plus Ty. So the vertical component would be 100 over 9 G squared. And that's going to be G times 10. No, let's work through G times square root of 100 times 1 over 3 plus 1 over 9. So that's equal to G times 10 times square root of what? 3 plus 1 is 4. So that's going to be G times 10 times 2 over 3. So that's going to 20 over 3G is the answer. Let's just check if that is the tension, 20 over 3G. And it is correct. So that's the solution for this particular problem.